Hello and welcome to this video in our series, A Beginner's Guide to the C Programming Language. In our last video, we wrote a C program with two different kinds of functions, the function main and the user-defined functions. We also understood how function calls are made and how recursive functions work. In this video, we will work with compiler directives, and I will explain to you how to use a few of the commonly used compiler directives in your programs. Before we start, make sure you are following us in this channel, like and share this video, and subscribe for notifications. In our video today, we will look at the compiler preprocessor directives like hash define and hash include, and then see how we can perform conditional compilation of our source code. We will also see some practical demonstrations of these compiler directives. As we have seen in an earlier video, the compiler compiles the source code in multiple steps. The first step is the preprocessor step, where the compiler performs the initial processing that is required for the compiler to be able to parse and compile the code. During the preprocessor step, the compiler will execute compiler directives. These compiler directives are embedded in the source code and start with the hash character. They are instructions to the compiler. When encountered in a source file, the compiler will perform these instructions as specified. The result of the compiler preprocessor step is a preprocessed output file that contains the final source code that is then compiled. Here is a list of some of the compiler directives we will discuss during this video. The first one is the hash define directive that is used to substitute symbol names with constant values as well as perform macro substitution. The hash include directive is used to let the preprocessor know which file needs to be loaded at that insertion point to add functions and other symbolic declarations. Then we will discuss a few conditional compilation directives like hash ifdef, hash ifndef, hash else, hash ndef, and hash undef. Let us start with the first compiler directive, that is the hash define directive. It is used to perform substitutions where a text in the code will be substituted with another value. Let us assume you have a simple expression in your program where you are calculating the area of a circle. The formula to calculate the area of a circle is 2 into 3.14 into radius into radius. Now 3.14 is a well-known value for the mathematical constant known as pi. If you are writing an application that deals with mathematical functions, it is highly likely that you would use this value very often in your programs. Now you could do it by writing the constant value as 3.14 wherever you need to, as we have done here. The other alternative is to use the symbolic name of pi so that anyone reading the program would know that we are using the value pi and not some constant that has a value 3.14. The second advantage is that once we have used the symbolic constant pi everywhere in our program, we can change its value in one place rather than have to make changes across the program. Let us see how. The hash define compiler directive is written as follows. Hash define symbol name followed by substitution value. Example, hash define pi followed by 3.14. Now in the program statement, we can rewrite the code as follows. Circle area is equal to 2 into pi into radius into radius. Now what the preprocessor does over here is replace the label pi with the value 3.14. Note that this is done during the preprocessor stage before compilation. So it is changed to circle area is equal to 2 into 3.14 into radius, which is what we want. After the substitution, the output of the preprocessor ensures that the compiler will have the actual statement that needs to be performed. As mentioned earlier, if you want to change the value of pi, let's say to have a more precise value like 3.1415, We need not make it in multiple places in our program, but instead do it just in the hash defined directive. Once this change is made, we can recompile the code for the change to be applicable across the code where it is used. The second use of the hash defined compiler directive is in macro substitution. A macro is a single or multiple lines of code that will be substituted by the preprocessor. Unlike the earlier substitution we have discussed, a macro substitution involves the replacement of macro arguments as well. The macro max takes two arguments a and b. The substitution value is a ternary operator that returns the larger of a and b. When used in the code as follows, m is equal to max of 10, 20, the preprocessor will substitute it as m is equal to 10 greater than 20 question mark 10 colon 20. Note that in this substitution, all occurrences of a is substituted with its actual value of 10 and the same with the macro argument b. A macro is used to make your code more readable. Note that it is a coding convention to write macros and symbolic constants in uppercase to distinguish them from function calls and other variable names. The second compiler directive that we will discuss today is the hash include directive. We know that every function needs to be declared. Functions in the C standard library are declared in header files. In addition, the header files also contain symbolic constants, user-defined types, etc. The standard C library has many functions which are split into multiple header files. These header files can be included in your programs with the help of the hash include directive. When the compiler encounters the hash include directive when preprocessing a C program, it reads the file name specified and creates a single file containing the original source file with all the included files contained in one target file. This target file is then compiled by the C compiler. The hash include directive has two versions. When you use the angled brackets to specify the file name, then the file is searched in the paths as configured in the project and solution file. If it is in double quotes, then the file is searched in the same directory as the source file. We will now look at some of the conditional compilation directives in C. A conditional compilation directive is used to conditionally compile a set of statements in your C program. Some of the conditional compiler directives are hash ifdef, hash if endef, hash else, and hash endif. The way these directives work is that if you define a symbolic value using the hash define directive, then the hash ifdef directive returns true if the symbol is declared and false if the symbol is not defined. The hash if endef directive is the inverse of the hash ifdef. It returns true if the symbol is not defined and vice versa. The above directive can have a hash else directive that will be executed if the hash ifdef or the hash if endef condition is false. The entire conditional compilation construct ends with a hash endif compiler directive. Within each of these directives, you can provide code that will be conditionally compiled. For example, if the symbol test is defined, then the statements within the hash ifdef will be compiled, and the statements within the hash else will not be compiled. Finally, the hash undef directive undefines a defined symbol. Let's now have a practical look at how compiler directives work. To start with, let's have a look at the hash include directive. I will use two library functions called printf and getchar. Both these functions are declared in the header file called stdio.h. The printf function will display data on the console, and the getchar function waits for a key to be pressed on the keyboard and returns a key value. If the stdio function is not included, it will give you a compiler error as shown here. The error says that the functions printf and getchar are not defined. Now, including the stdio.h file will resolve the syntax error, and we can build and execute the program. Note that we are using the right angle brackets to specify that the file is located in the include directory that is set in the environment. So the include directive adds the contents of the specified file, in this case stdio.h, into the source code at the point it is defined. This happens when the source code is being pre-processed during the compilation. Now let's have a look at the hash define directive. We will calculate the area of a circle using the formula 2 pi r square. Let's single step through this program. Here the value of pi is the constant 3.14 in the expression. Let's create a symbolic label for this constant. As shown here, this is done using the hash define directive. We execute the program once again, this time with the symbol defined. As you can see, the result is exactly the same. What the compiler preprocessor does is replace the symbol pi in the expression with the value 3.14. Now we can change the value of pi to be more precise and rebuild the program. When executed again, you will see that the new value of pi is used. The result is a more precise value of the area of this circle. Let us now see how macro substitution works. We have declared a macro called max and the substitution string that is a ternary operator. The macro takes two arguments, a and b, which are used in the ternary operator. The macro is used in a program statement within the function main. We have two statements using the macro. Each one of them uses different arguments. When the preprocessor encounters the macro in the statement, it will replace it with the actual macro statements, replacing the arguments correctly. So in the first program, it gets replaced with the statement 10 greater than 20 question mark 10 colon 20. And in the second, it gets replaced with 30 greater than 10 question mark 30 colon 10. As you can see, both these statements return the max value of its two arguments. Finally, let's have a look at conditional compilation. We have a symbol called test, and in the function main, we are conditionally compiling the two printf statements, one when test is defined and one when test is not defined. This is done in the hash else body. As you can see, the color of the printf statement within the hash else part of the compiler directive is grayed out because it will not be included in the compilation process. When you execute the program, the first printf statement is executed. Now we can remove the test declaration. You can see that the statement with the hash ifdef body is grayed out and the hash else body is highlighted. When you execute the code, the second printf statement is executed. So conditional compilation directives are used to conditionally compile program statements. The most common use of conditional compilation directives is when you write code for multiple platforms like Unix and Windows and use conditional compilation to select which code to compile during that compilation process. So we have reached the end of our discussion on compiler directives. We covered the hash include directive and seen how symbolic constant and macro substitutions are performed using the hash define directive. And finally, we performed conditional compilation. Please follow us, like and share this video, and enable notifications on our channel. In our next video, we will use some simple functions in the standard C library. These are simple input and output functions like getchar, printf, and scanf. Thanks for joining us, and see you again next time.